Welcome back, everyone, to the deep dive. Today we're going to be looking at some really interesting research
Oh, yeah.
coming out of the Intelligent Robotics Laboratory at Skulltech.
Okay.
They published a paper, and
Interesting.
it's called
Mm.
Industry 6.0, New Generation of Industry Driven by Generative AI and Swarm of Heterogeneous Robots.
Wow.
And what really caught my eye
Uh-huh.
was just this idea
Okay.
of fully automated manufacturing.
Yeah.
So think like AI and robots handling everything,
Right.
from like product design
Wow.
all the way to assembly.
So like start to finish.
Yeah, like the whole process.
That's pretty ambitious.
Yeah, it's a bold concept.
It is.
What I think is really striking is that
Yeah.
they're trying to completely remove humans
Interesting.
from both the design
Cool.
and the production process.
So like no human intervention at all.
Yeah, basically you describe a product you need,
Right.
and then the system
Oh, wow.
makes it happen.
Like just poof, it's there.
Yeah, pretty much.
That's amazing.
So it goes from like the digital blueprint to a physical object.
Yeah. How does that even work?
Well, so they propose this 4-stage process. And
Okay.
it starts with what they call blueprint generation.
All right.
And this is where generative AI comes in,
Makes sense.
specifically LLMs.
Yeah. Large language models, right?
Exactly.
Okay.
So you, the user,
Yeah.
you give a natural language description of what you want the product to be.
Uh-huh.
And the LLM takes that description
Okay.
and generates a 2D signed distance function,
Okay.
or SDF.
Right.
And that defines the product's geometry.
Okay.
Then from there,
Yeah.
the LLM creates a 3D model,
Uh-huh.
which is like an STL file format.
Okay.
And finally, it converts that 3D model
Okay.
into G-code,
G-code.
which are the instructions for 3D printing.
That's really interesting.
Yeah, so in like a few minutes,
Wow.
you go from like a basic idea
Yeah.
to a digital blueprint
That's amazing.
that's ready for manufacturing.
So what happens next?
So then the next stage is
Uh-huh.
what they call part production.
Right.
And that's where the 3D printers come in.
Okay.
Based on those LLM generated instructions,
Right.
they create all the little individual components of the product.
Makes sense.
Once the parts are printed,
Yeah.
a robotic arm
Okay.
picks them up
Mhm.
and moves them onto a drone.
Wait, a drone?
Yeah, a drone.
Oh,
They're proposing to use a flying conveyor system.
interesting.
So the drone basically transports the parts
Oh.
to the assembly station.
All right.
And it uses a Vicon tracking system
Okay.
for like really precise positioning,
Got it.
and then an onboard computer for navigation.
Oh, that's cool. So the drone like flying around the factory.
Yeah, it's like
That's
parts are whizzing through the air on these drones.
It's like something out of a movie.
It is kind of futuristic.
Who is?
So then
Wait, what happened?
we get to product assembly.
Right, the final stage.
Exactly.
Okay.
So there are 2 robotic arms,
Right.
and they're guided by, you guessed it, LLMs.
Of course, the LLMs are running the show.
Yeah, they're everywhere in this system.
Yeah.
So the LLMs provide step-by-step instructions
Okay.
to these robotic arms,
Uh-huh.
and they even determine which robot is best suited to do which action.
So they're like coordinating the whole assembly process?
Exactly.
Exactly.
It's not just the design.
Right.
The LLMs are literally orchestrating the whole production line.
Like a conductor
Yeah.
with the robots as the orchestra.
It's a highly integrated system
It is.
with AI at the helm.
So this is all very cool.
Yeah.
But I have to ask.
Yeah.
What about the humans?
That's a great question.
Like, where do they fit in?
Well, the researchers actually addressed that head on.
They do?
They did this really interesting user study.
Okay.
They called it human versus robot.
What?
Yeah. They pitted their Industry 6.0 system
Wow.
against human experts.
That's gutsy.
Yeah. And the goal was to design and manufacture a simple gripper.
Oh, so like a head-to-head competition.
Exactly.
I love it.
So I'm curious, what do you think who came out on top?
Well, I mean, robots are pretty fast,
Yeah.
but humans are pretty clever.
True.
So I'm not sure it's a tough one.
Yeah. It's hard to say.
I guess we'll have to see.
Yeah, we'll delve into those results, and I think you'll be surprised.
Okay, I can't wait.
But first, we need to dig a little deeper into how this system actually works.
Yeah, let's do it.
And how those different AI models stack up.
Right, because they tested a bunch of different LLMs, right?
They did.
Okay, so let's talk about that.
Let's do it.
So, all right, we're talking about this Industry 6.0 system,
Yeah.
AI and robots doing all this manufacturing.
Right. All automated.
But it's still kind of theoretical, right?
It is.
Until we actually,
Yeah, see how it works?
see it in action.
Exactly.
So the researchers, they spent a lot of time
They act-
evaluating different LLMs,
Mhm.
different large language models.
Right.
That was a big part of their paper, wasn't it?
Yeah, they tested a whole bunch of them.
Oh, really?
9 different ones.
Wow.
Including some of the really powerful ones.
Yeah.
Like, OpenAI's GPT-4o
Right?
and Google's Gemini 1.5 Pro.
Yeah, those are the big ones.
But they also included some of the smaller, faster models.
Okay.
And even a few open source options.
Interesting. So like a good mix.
Yeah, they wanted to be comprehensive.
Makes sense. And it makes sense that they focused on LLMs.
Right.
Because they're so crucial to this whole Industry 6.0 idea.
Exactly. Without the LLMs, you don't have the system.
Right. But evaluating them in this kind of robotic system,
Yeah.
it must have been tough.
It was definitely a challenge.
Yeah.
They had to break it down
Okay.
into like manageable chunks.
So how did they do that?
So they focused on 3 main things
Right.
in the blueprint generation process.
Okay.
First, they wanted to see,
Yeah.
could the LLM accurately understand
Oh, okay.
what the user wanted?
Right. So analyze the input
Ex-
and figure out the mechanism.
Mm-hmm. Okay.
Second, could it generate
Yeah.
the executable Python code
Okay.
for that SDF mechanism?
Yeah.
Like, essentially turning that understanding
Right.
into instruction.
So translating it.
Yeah.
Okay.
And then finally, the big one,
Right.
could it produce
Yeah.
a functional STL file?
3D model.
Exactly the one that's used for 3D printing.
Right. So like real world outcomes.
Yes, exactly.
Not just theory.
They wanted to see if it actually worked.
Okay.
So for each of these aspects,
Yeah.
they had a really simple scoring system.
Oh, really?
Success or failure.
Oh, wow.
No partial credit.
So the LLM either did it
Yeah,
or it didn't.
exactly.
Okay.
So what do you think?
Yeah.
What were the results?
Well, I'm guessing the bigger, more powerful models probably did the best.
You are correct.
I knew it.
Both GPT-4o
Yeah.
and the O1 preview model,
Right.
they aced the first 2 tasks.
Okay. Analysis and code generation.
Not surprising.
And they also had the highest success rate
Okay.
with the STL files.
Makes sense. They've got all that data.
Yeah, they're trained on massive data sets.
Right.
But there were a few surprises.
Oh, really?
Claude 3.5 Sonnet,
Okay.
another commercial model.
Mhm.
It actually did almost as well as
Interesting.
the top 2.
So not just the biggest models.
Right.
Okay, what about the smaller ones?
As you might expect.
Yeah.
They struggled a bit.
Yeah. Especially with the STL files.
Exactly.
That was the hardest part.
It was the most complex.
Right.
And those open source models,
Yeah.
they really had a tough time.
Makes sense.
They just don't have the same resources
Oh, yeah.
as those big commercial models.
So it seems like that classic trade-off
Yeah.
between size, speed, and capability,
Mhm.
it's still there.
It's still a factor.
Even with these advanced LLMs.
And of course, you can't forget about cost.
Right.
Those top tier models,
Yeah,
they're expensive to run.
they are.
They need a lot of computing power.
Uh-huh.
But the researchers make a good point.
Okay.
Even the best LLMs,
Yeah.
they're not perfect.
Right.
They all had some trouble
Okay.
as the tasks got more complex.
So there's still room for improvement,
Definitely.
even with the state of the art.
Exactly.
Okay.
Especially with those STL files.
Yeah.
That was a big hurdle
I see.
for all the models.
Interesting.
So it's a reminder
Yeah.
that we're still early
Right.
in this whole
Mhm.
process
Very days.
of using LLMs
Mhm.
in these complex robotic systems.
Right. So a lot of potential,
Tons of potential.
but still a lot to figure out.
Exactly.
So they did this user study, right?
Oh, yeah.
Where they compared the system
Yeah.
to human experts.
Human versus robot.
I love that.
It was pretty cool.
Yeah.
It shows how confident they are in their system.
They're putting it to the test.
Yeah, head to head with humans.
So how did they set it up?
They had 10 participants,
Mhm.
all with backgrounds in
Yeah.
mechanical design
All right.
and 3D printing.
Makes sense.
And they each had to design, manufacture, and assemble
Okay.
at Simple Gripper.
Right. The same task as the system.
Exactly.
Okay.
And they measured how long it took them.
Right. For each stage.
Yeah.
And then compared that to the system's performance.
Exactly. It was like a real world benchmark.
Cool.
So as we mentioned before,
Yeah.
the Industry 6.0 system
Mhm.
was over 4 times faster
Wow.
overall.
Okay. But that speed advantage,
Yeah.
it mostly came from the blueprint generation.
Right?
That's where the system really crushed it.
Yeah, it was 47 times faster.
47 times than the human experts.
That's insane.
I know it's amazing how quickly those LLMs
Yeah.
can generate designs.
Right.
But there's a catch.
Oh, okay.
The human participants
Yeah.
were actually 10 times faster
Wow.
at the assembly stage. So
Well,
we
but-
still have the edge
Okay.
when it comes to dexterity, right? That fine motor control.
Exactly.
But for how long, though?
That's a good question.
Because
Brett.
those robots are getting better.
They are.
AI is advancing.
Mm-hmm.
So, will there be any tasks left
Yeah.
where humans are still better?
It makes you wonder.
It does.
And at least it's like the bigger question.
Yeah.
What happens to jobs?
Right. What about the humans?
If robots can do all this,
If they can do everything,
Yeah.
what are we going to do?
that's a big question.
It is a big one.
And we'll have to explore that
We
in the next part of our deep dive.
I can't wait.
Okay, so we've talked about jobs.
Right.
But I want to go back to those 2 paths for Industry 6.0
Oh, yeah, the two
that the researchers talked about.
Yeah, it's like a fork in the road.
Exactly. And they both lead to very different places.
So on one path,
Yeah.
we have what they call personalized production.
Okay.
So imagine a world where you can order like a custom designed product
Oh, wow.
made just for you
Yeah.
with all your specific needs. Okay.
And then it gets manufactured and delivered in just a few hours.
Like super fast turnaround.
Yeah, incredibly fast.
So basically it's like having your own personal factory.
Exactly, like it's at your fingertips.
Wow, that's pretty amazing.
Think about it. You could order
Yeah.
custom sneakers
Okay.
that like adapt to different types of terrain
Oh, that's cool.
or a prosthetic limb
Okay.
designed specifically for your body
Right.
and how you move.
It's like mass customization.
Yes,
Yeah.
but taken to like the next level.
Right, like the ultimate level.
Exactly.
So what kind of implications do you think that has?
Well, I mean, it could be huge. Like
Yeah.
it could completely disrupt entire industries,
Wow.
change how supply chains work,
Right.
and even like fundamentally change
Okay.
how we buy things and use things.
I mean, it makes sense.
And think about waste.
Yeah,
There'd be so much less waste.
because everything is made to order.
Exactly just what you need.
Wow, it's really mind-blowing.
But then there's that other path,
Right.
autonomous optimization.
Yeah, this one's really interesting.
Yeah, it takes automation
Huh.
to a whole other level.
It's not just about robots building stuff.
Right.
It's about factories that can basically run themselves.
Oh, like, no humans needed at all.
Exactly. The factory manages itself.
Wow.
So think about it.
Yeah.
A factory that can adjust its production
Okay.
based on like real-time demand.
So if demand goes up,
It ramps up production.
and if it goes down,
It slows down.
so no more overproduction.
Exactly. No more waste.
It just makes what's needed.
When it's needed.
That's incredible.
And it goes even further.
Oh, really?
It's not just production levels.
Okay.
It's also things like energy use.
Okay.
How much material it's using, even like waste reduction.
So it's constantly optimizing.
Yeah, it's like it's always learning,
Wow.
finding ways to be better.
And all without human input.
Exactly.
So it's like a super intelligent factory.
A sustainable one, too.
Right, because it's not wasting anything.
Exactly.
It's pretty impressive.
It is a pretty compelling vision.
But it does bring up that big question again.
Yeah.
What about the humans?
Where do we fit in?
If the AI and robots can do it all.
Right. Design, produce, optimize.
Yeah,
I don't think there's an easy answer.
a tough one.
But some experts think
Yeah.
that we'll see new types of jobs emerge.
Okay.
Jobs that require different skills.
Like what kind of skills?
Things like AI programming,
Okay.
robotics maintenance,
Right.
data analysis.
So we'll need to adapt.
Yes,
We
exactly.
need to learn new things,
And work alongside these systems.
but not replaced.
Right. We become more like
Okay.
the overseers.
Right.
Making sure everything runs smoothly.
Ethically and efficiently.
Exactly.
And maybe it'll free us up
Potentially.
to do more creative things.
Yeah, like things that are more fulfilling.
Because we're not stuck doing
Yeah.
repetitive tasks.
Yeah, the robots can handle that.
So it could change how we work.
And how we live.
Yeah.
How we think about our place in the world.
There's a lot to consider.
It is. It's a big shift.
And we need to be prepared.
Yes. We need to think about education and training
Right.
so that people have the skills they need
Exactly.
to thrive in this new world.
It's about being proactive.
Yes.
We need to shape this future.
It's not predetermined.
Right. We have choices to make.
And we need to make them wisely.
And to do that,
Yeah,
we need to understand this technology.
absolutely.
Its potential,
That its limitation.
this deep dive.
Yeah,
It's been really eye-opening.
it has.
We've talked about cutting-edge tech,
Right.
the future of work,
Yeah.
even some big philosophical questions.
It's been a great discussion.
It has, and it shows
Yeah,
how important it is to stay informed
absolutely.
about these emerging technologies.
Because they're going to change everything.
So to wrap things up,
Okay.
I want to leave our listeners with a challenge. Stay curious,
Yes.
keep exploring,
Definitely.
and don't be afraid to ask the tough questions.
Good advice.
The future is being written right now,
Yeah.
and we all have a role to play.
So let's get to work.
Thanks for joining us on The Deep Dive.